right, we're going to take a look at factoring using the sum and difference of cubes. So we've looked at squares before, now we're going to look at cubes, and cubes are just numbers where you can think of another integer, multiply it by itself 3 times, and get your cube. So for example, 8 I could think of as 2 times 2 times 2, right? 2 times 2 is 4, times another 2 is 8. I could also write 2 times 2 times 2 as 2 to the 3rd power, or 2 cubed. So there are all kinds of numbers that are cubes, and it's really helpful to have a list of them. You probably have a list of them in your notes, but let's go ahead and put them here as well. So 1 cubed is, of course, 1. 2 cubed, this is my little list. 2 cubed is going to be 8. 3 cubed, that's 3 times 3 is 9, times another 3 is 27. 4 cubed. 4 cubed is, let's see, 4 times 4 is 16. Times another 4 is 64. 64 is also a perfect square, right? So I could take the square root of 64 and get 8. But in this case, we're thinking about it as a cube. 5. So let's see. 5 cubed is 125. 5 times 5 is 25, times another 5 is 125. 6 cubed, 6 times 6 times 6 is 216. And, well, let's do just one more, because I'm running out of room over here. 7 cubed. So 7 cubed, 7 times 7 is 49, times another 7 is 343. So this is a list of perfect cubes. And probably a good idea to have them easily on hand, just so you're not trying to search for what those numbers are. All right, let's take a look at a couple of examples. So here's example 1. X cubed plus 64. So I am adding here. I'm adding 2 cubes. I know they're 2 cubes, right? I've got an x cubed, and I've got 64. 64 is in my list. 64 is really 4 cubed. And my variables are always going to be cubed as long as the exponents are divisible by 3. So x cubed is a cube. X to the 6th is a cube, right? X, let's see, x to the 9th, would that be a cube? Yes. X to the 10th, is that a cube? No, that's not a cube because 10 is not divisible. Not divisible by 3. What about x to the 12th? Yes, because 12 is divisible by 3. So as long as my exponent is divisible by 3, then that would be a perfect cube. So x cubed is definitely divisible by 3. 3 divided by 3 is 1. All right, the other thing that I'm going to need besides making sure that I have 2 cubes is a formula. And the formula is in your notes also, but I will give it to you here. It looks like this. So if I have something being cubed plus something else being cubed, so a cubed plus b cubed, I can factor it by creating 2 factors. Whatever that cube root is for a and whatever it is for b, a plus b, times whatever a is squared minus whatever a times b is plus whatever b is squared. So that's kind of weird looking. You can prove to yourself that they're actually the same thing by FOILing out this side with this side. So you can multiply those two together and you'll find that it does indeed equal a cubed plus b cubed. So you're more than welcome to do that. But for right now, what I'd like you to focus on is just using this as a formula to figure out what the factors are of something cubed plus something else cubed. All right, so let me just put a little box around that. Here's my formula. And this one is for the sum of 2 cubes. I'm adding 2 cubes together. All right, I've got my formula. I know that I've got 2 cubes. What do I do next? Well, what I do next is figure out what a is and what b is. Now, a is not x cubed. A is whatever the cube root of x cubed is. So A is just plain old x. What about B? B is 64. No, B's not 64. It's the cube root of 64. So I come over here to my little list. What is the cube root of 64? What times itself? 3 in a row is 64. It's 4. So B is 4. Now I'm ready to plug those things into my formula. All right. First thing says A plus B. Okay, first factor, x plus 4. There's A plus B. Second factor, second thing, A squared. All right, that's x squared. Minus A times B. So minus A times B. Well, I'm going to write it as B times A. 4x. 4, oops, where'd my pen go? There it is. 4x. And then plus B squared. Well, B is 4. B squared. So let's see. 4 squared. That would be 16. So plus 16. And there it is. My factored answer. If I'm trying to figure out the difference of two cubes, so here's my second example. It's going to look a lot like the first example. So example 2. The only thing that's going to look different about the problem is subtracting. So let me zoom out here so you can see these two. Here's my first example, x cubed plus 64. Here's my second example, x cubed minus 64. They're both still cubes, but now I've got a subtraction going on here. So I need a slightly different formula. It will look very similar to the one in red. This one I'm going to put in green. This is going to be the difference of two cubes. Fit that right in here. All right, so the difference of two cubes. So I've got something cubed minus something else cubed, and I want to factor that. Here's what it looks like. First factor, is going to be A minus B. So the cube root of A minus the cube root of B cubed. Second factor looks really similar. It's also going to be A squared, but then it's going to be plus A times B and plus B squared. So there are a couple things that are different here. First thing is that we're subtracting. Second thing is that we're adding here. So these are the places that are different. All right, let's do this problem. Step 1 is to figure out what A and B are. A is x. Remember, the cube root of x cubed is just x. And B is just 4. The cube root of 64 is just 4. And now I'm going to plug it all into my formula. A minus B is x minus 4. There's my first factor. So I got my parentheses up here. There we go. Second factor is x squared plus A times B. That'll be 4x. And then B squared is going to be 4 times 4 again, or 16. And there we have it. Here's my answer. X minus 4 times x squared plus 4x plus 16. Let's do one more. Oh, I think I've lost a digit here someplace. All right, here's example 3. Okay, I'm subtracting two things. It could be that I have difference of two cubes, but we better check our list here. So I know the x is cubed. 27, let's check 27 out on the list. 27, oh yes, here's 27. Cube root of 27 is 3, so that's good to go. What about that second term? 343. 343, oh, yep, there we go. That's also a cube. Cube root of 343 is 7. Now we're good to go. Step 1, figure out A and B. A is the cube root of 27x cubed. So that's going to be just 3x. Cube root of 343 is 7. Now we plug it into the formula. So let's write that formula down again. A minus b times a squared plus a times b plus b squared. All right, a is 3x, so 3x. B is 7 minus 7. A squared. So what's 3x squared? Well, 3 times 3 is 9, and x squared is just x squared. What about a times b? A times b. That's going to be 3x times 7. Let's see, that's going to be 21, right? 3 times 7 is 21. So AB is going to be plus 21x. One more to go here. B squared. B is 7. And what's 7 squared? 49. And I think we're done. We've factored 3x minus 7 and 9x squared plus 21x plus 49. Yay!